We are looking at calorimetry. Calor meaning heat, metry meaning measuring. If I add heat to water, the temperature rises, and of course if I remove heat energy from water, the temperature falls. How much the temperature rises depends on how much heat energy I add, how much water there is. The liquid can also be changed, but we will always use water or a dilute aqueous solution that will pretend as water. This formula here will always be provided for you. Q is the heat energy in joules. M is the mass in grams for the water. Note for water, 1 milliliter is the same as 1 gram. C is a specific heat capacity constant, 4.18 joules per gram per degree Celsius. That constant will always be provided for you, and delta T is the change in temperature. How do we use Q equals MC delta T? Well, Robin goes camping. He heats 150 milliliters of water. The temperature rose from 20 degrees Celsius to 97 degrees Celsius. How much heat energy did the water get from Robin's camp stove? The C for the water, the specific heat capacity for the water, is 4.18. The mass is 150 grams because 150 milliliters of water is 150 grams. C is 4.18. Change in temperature is 77 degrees. Q equals MC delta T, 150 times 4.18 times 77, 48,279 joules. How would we measure this experimentally? Well, in industry they would use a bomb calorimeter that would look like this. In a school lab we have nothing anywhere near so complicated. We have polystyrene cups. How do I use that to calculate the change in enthalpy? Delta H equals minus Q over N. Delta H is the change in enthalpy in kilojoules per mole. The subscript R just means reaction. You could think of it as random, so it applies all of the time. The heat energy in kilojoules is minus Q, and N is the amount in moles. Robin's camp stove burns butane. The mass of butane burnt in this case was 1 gram. What's the molar change in enthalpy for burning butane? Note you're given the molar mass of butane as 60 grams per mole. The heat energy absorbed by the water from 3 slides ago was 48,279 joules, which would be 48.279 kilojoules. The amount in moles is the mass over the molar mass, which is 1 over 60, which is 0.01667. The molar change in enthalpy is negative Q over N, negative 48.79 divided by 0.01667. Is that number? Negative 29,000 kilojoules per mole, to 3 significant figures. The confusing part is what goes where. Often students confuse the M in QC equals MC delta T and the M in amount in moles is mass over molar mass. The M, the mass, and Q equals MC delta T is the mass of the water or the solution that changed temperature, the water that's getting heated up. The mass in N equals M over M is the mass of the chemical we want the molar enthalpy change of. Normally it will have the molar mass given. So in this question here, which you can link to, 2.28 grams of methanol is combusted. The temperature rises. The temperature of 100 grams of water rises, initially starting at 20.6 degrees Celsius. Calculate the final temperature of the water. The molar mass of methanol is 32.0 grams per mole. There's the specific heat capacity of water. There's the molar enthalpy of combustion of water. For the Q equals mc delta T, we use 100 grams because that's the water, that's the mass of water that had the temperature change. See, right here, mass of water, the temperature changes is 100 grams. For the N equals mass over molar mass, you use 2.28. 2.28 grams of methanol. Oh, and look, here's the molar mass of methanol. These two match. So I go 2.28 divided by 32. Thank you.